This video will walk you through the computer simulation for Lesson 7 of Ecosystems. To complete this lesson, you will need a personal copy of the student activity sheet to record your answers and collect your data. Let's begin. Investigation 1 looks at what happens to the buffalo population under relatively stable conditions. Before we start collecting our data, please pause this video and answer question 1 on your student activity sheet. Okay, let's start collecting data. This is what our computer simulation looks like. You may have seen a NetLogo simulation that looks similar to this, as we've used them earlier in the school year. We have our 3 different regions separated by buffalo fences to represent the idea that buffalo do not migrate. We have our initial population sizes here. And then, as you will see, as we run the simulation, a graph is generated of the buffalo population size. So for investigation 1, we're going to start with our initial population of 10 buffalo. As you can see here, I've already set up the simulation to run starting at 10 buffalo. So then we hit setup and go, and then we watch. We can speed the simulation up here, which just increases the rate of time, which is represented by ticks in this simulation. And over here, you can see the simulation generating a graph of our population of buffalo. We're going to let this run until about 1,500 ticks. And lucky for you, I'm going to do the cooking show version of this, where I've already run the simulation under the various conditions, and we can just record our data. So if you look here, when I started with 10 buffalo, after about 1,500 ticks of time, this is the graph that our buffalo population creates. In your student activity sheet, please pause this video and record your observations when we start with 10 buffalo. Okay. In our second trial, we're going to start with 25 buffalo. As you can see, I've already run the simulation, starting with 25 buffalo, and this is our data. Please pause the simulation and complete your observations for 25 buffalo. Next up, we ran the simulation at 50 buffalo. Pause this video and record your observations for 50 buffalo. Next up, we have 75 buffalo as our initial population. So go ahead and pause this video and record your observations for 75 buffalo here. And last but not least, we start with 100 buffalo. What happens to the buffalo population size? As you can see, we have 10 buffalo starting, 25 starting buffalo, 50 starting buffalo, 75 starting buffalo, and 100. Make sure you have something for observations for all of those trials. When you've done that, please answer questions 3 and 4 on your student activity sheet. Pause this video to do that now. For investigation 2, we're going to look at a change in the climate and how a change in the climate impacts the buffalo population. Before we start collecting our data, please answer questions 5 and 6 in your student activity sheet. Okay, so for trial 1, for investigation 2, we're going to set our grasslands, our central grasslands, at 80% grass. We are going to incorporate buffalo fences. We are not going to incorporate seasonal rain, and then we're going to run the simulation and record the number of buffalo. So you can see I have 80% grassland, starting with 10 buffalo. I have buffalo fences, but I don't have seasonal rain. In the interest of time, I'm doing this cooking show version of this. So here's what we look like after about 1,500 ticks. 28 buffalo. So we'll record that number in our student activity sheet. We'll run the simulation again for trial 2. This time, we're going to incorporate buffalo fences and seasonal rain. When I run that simulation, 80% grass, buffalo fences and seasonal rain, starting with 10 buffalo. I end with 52 buffalo. Here's a graph of that population throughout the time. For trial 3, same percent grass. I'm going to remove those fences and I'm going to incorporate seasonal rain. Now you can see what happens when there are no fences. Still starting with 10 buffalo, 80% grass. We end with 137 buffalo. Wow, that's a really big difference from what we'd seen before. And then for the 4th trial, the instructions say that we get to choose. So for this one, I eliminated buffalo fences and I said no to seasonal rain. And when I ran that simulation, I ended with 147 buffalo. So you can see a graph of the buffalo population over time here. And I ended with 147 buffalo. What do you notice are the differences between the impact of seasonal rain and the impact of buffalo fences on the overall population of buffalo? Write down some of your conclusions for question number 8. Moving on to investigation 3, now we're going to look at how the introduction of rinderpest impacts the buffalo and the wildebeest population. So you may have noticed that we were only looking at buffalo before, and now we're going to add wildebeest into our ecosystem and see what happens. So I'm going to start my simulation with 10 buffalo and 10 wildebeest. I'm back up to 100% grass. I have incorporated seasonal rains and I have incorporated buffalo fences. And then I also clicked on the wildebeest migrate. This is because, as you learned in a previous lesson, the wildebeest migrate and the buffalo do not. So I'm going to hit set up and then go. I'm going to speed this up a little bit. And then when we get to about 500 ticks of time, I'm going to infect 25 buffalo. Notice that wildebeest migration. Wow. How do you think that impacts their population size? Okay, now I'm going to infect about 25 buffalo. You can see that the infected buffalo are the ones with circles, but now there are also wildebeest that are infected with rinderpest, even though I only infected the buffalo. That's called a spillover event. When an infection goes from one species to another. Okay, so I did the cooking show version of this. Fast forward to about 2,000 ticks, just so we can see a longer effect. And here you can see a graph with both our wildebeest population changes, wow, and our buffalo population changes. So after you answer those prediction questions, please answer questions 12, 13, and 14. So pause this video and answer questions 12, 13, and 14. As you read in a previous lesson, the rinderpest virus affected not only wildebeest and buffalo, but also the cattle, which were the domesticated animals. And scientists developed a vaccine for rinderpest and were able to vaccinate the cattle. So for investigation 4, we're going to run the simulation just like we did, but we're going to vaccinate cattle. We're going to simulate vaccination of cattle and see how the population is impacted there. So once again, I ran the simulation. I infected 25 buffalo, just like I did in the previous simulation, at around like 500. And I let the simulation run for about 500 more ticks. And then I vaccinated, it was like maybe closer to 700 when I infected them, and then 1,300 ticks when I vaccinated them. And this is what we get. When we start with 10 wildebeest and 10 buffalo, we infect buffalo at about 700 ticks, and then we vaccinate cattle around 1,300 ticks, and then we let the simulation run for about 2,000. So in your student activity sheet, hopefully you already answered the prediction question, my bad. And then look at that data from the video from the simulation to answer questions 16 and 17. The conclusion questions require you to provide evidence from the simulation, so you might need to rewatch this video a couple of times or rewind and pause to get some evidence. But now answer questions 18 through 21 as conclusion questions, providing evidence from the simulation where needed.